Yet another case of a seemingly habitable world orbiting an M-type red dwarf has surfaced. Just 40 light-years away, a super-Earth exoplanet has been found that seems to have, at least on its face, the best chance of detecting Earth-like habitability that we have yet seen. Known as LHS 1140b, this planet has some significant differences with Earth. For one, it's about 1.4 times the size of our planet and thusly would have higher gravity. Its mass suggests that it's rocky, like our inner planets, which favors complex life. Planets within the habitability zones of red dwarfs need to orbit very closely. LHS 1140b, for example, orbits so close that its year is only 25 days, so it would probably be tidally locked to its star, and perhaps make it an eyeball world with a habitable twilight area, as some models of TRAPPIST-1 and its planets suggest. See my videos on that system on this channel. Yet, even at this distance, LHS 1140b still only receives about half as much light from its star as we do from ours. Still, that's enough to maintain liquid water, at least on parts of the planet. And unlike stars such as TRAPPIST-1, which are thought to have been extremely active in their youth for a long period of time, and might have stripped their worlds of their atmospheres, LHS 1140 is thought to be a relatively stable, quiet star that had an active phase early in its life that lasted only about 40 million years. TRAPPIST-1, by contrast, was more to the tune of 1 billion years of activity. With the discovery of first Proxima b and then the TRAPPIST-1 system, exoplanets within the habitability zones of red dwarf stars is a very active area of study. This is because planets within those zones are easier to see if you're dealing with a red dwarf, as opposed to brighter stars like our Sun. You could say that there is a sweet spot between stars that are too hot and bright and stars that are too dim to be suitable for studying transiting exoplanet atmospheres. But it goes deeper. It's not yet clear how habitable red dwarfs are. Only observations of exoplanets orbiting them will tell. But they are by far the most common type of star in the galaxy. Calm, stable stars like our Sun are much harder to come by, and the habitability question of red dwarfs will figure prominently in determining how common life is in the universe. But studying exoplanet atmospheres is a tricky thing. There are actually quite a few more detections of potentially habitable planets in our galaxy that come from the Kepler spacecraft, but their atmospheres aren't easy to study due to them being very distant, at least as far as detecting gases associated with life are concerned. But even when exoplanets are close, it's still not easy. In the case of Proxima b, for example, it was discovered through its gravitational effects on its star. Think of it tugging on the star, and astronomers can detect that wobble and infer a surprising amount of information from that. That's how LHS 1140b's density was determined. But what Proxima b doesn't do is pass in front of its star within our line of sight, which makes studies of any atmosphere that may be present exceedingly difficult. And another problem faces those wishing to study TRAPPIST-1. Looking for biosignatures in the atmospheres of its worlds is difficult because of the nature of the star itself. While it is a star, it's as small and cool as they get. That means it's dim, and that means it's hard to use it to look at spectra passing through planetary atmospheres to look for things like oxygen, which, if found, could suggest that life is present. This makes LHS 1140b an attractive candidate as a starting point of studying exoplanet atmospheres for signs of life. Since the planet has higher gravity, it can better hold on to an atmosphere, and when you know the density of a planet, you can determine how tightly it holds on to that atmosphere. Plus, since the star was only active for 40 million years in its youth before quieting down, that also favors habitability. And since that active period would have happened shortly after the formation of the system, even if the planet did lose its atmosphere, it might have been replenished by way of gases and water released by a still molten surface. How much water might be present on such a world and how much ultraviolet light and radiation bathes a planet remains to be seen, though the star seems to spin slowly, which bodes well. So LHS 1140b is the top current candidate for scientists to look at for biosignatures, and the good news is that they certainly are looking. The team studying the system, led by Jason Dittman of the Harvard-Smithsonian Center for Astrophysics, linked to their press release in the description below, are actively studying it to pin down the conditions in which this planet exists. Using the Hubble Space Telescope and a whole array of ground-based telescopes later this year, they will try to see an atmosphere and figure out what it's like. If oxygen is found, in the future, instruments such as the James Webb Space Telescope and the Giant Magellan Telescope will allow scientists to determine if that's due to the presence of life.